Welcome back to Code and Current Studio. Today we're diving into one of the most versatile components in Arduino projects, the keypad. In this mini project, we'll use a 4x4 keypad to control two operations, a simple calculator and a servo motor. This is a great way to learn how keypads work and how they interact with other components like LCDs and servos. The materials needed for this project are the Arduino board, 4x4 keypad, 16x2 LCD, servo motor, and some jumper wires. The keypad connects to pins 2 through 9 on the Arduino. The LCD uses SDA and SCL pins for I2C communication, and the servo connects to the PWM pin 10. Make sure all components share common ground and proper power connections. Let's take a deeper look at the code that makes the keypad operate and function correctly. This section is essential because it defines the keypad layout, wiring, and creates the objects that allows us to read key presses easily. We'll break down each line so that you understand what it does and why it matters. The include keypad. This line of code includes the library for the keypad, which provides functions to scan and detect key presses. The const byte rows equals 4 defines the number of rows and columns in the keypad. Char keys creates a 2D array representing the keypad layout. Each character corresponds to a physical key. Byte row pins, byte row column pins lists the Arduino pins connected to the keypad, rows, and columns. Keypad equals keypad creates the keypad object using the function layout and pin configuration. This allows you to call keypad.getKey function to read key presses. All right, let's start our simulation. We can look through our code quickly. So we can see here we've got two options to select from. One of them is going to be the calculator and one of them is going to be the servo. So we can select one to go into the calculator. So I've pre-programmed each button, so I kind of know what each one does. The numbers are numbers. The A through D are the functions of arithmetic, and the plus, or the hashtag here, is equals, and then the asterisk is to back out of the program. So we can say, 2 plus 9 equals, or we can say, 6 times 4 equals 6 divided by 5 equals. And then when we're done, we can back out. Go into our servo program, servo control, press 1 through 9. So each one of the buttons is going to represent a direction that the servo will shift into. So we can see that the servo would point up towards the 1, we can make it point up towards the 3, point to the 6, 9. If we wanted to jump around a little bit, we could make it point to the 2, over to the 4, and then if we press the 5, turns on spin mode. Does a little dance for us back and forth. And then we can back out. Try adding new features, decimal input support, custom servo pattern, or speed control. Share your ideas and improvements in the comments. Congratulations, you built a dual function Arduino project using a keypad and learned how one component can control multiple operations. This keypad component deep dive is the first in our keypad series. Up next, using the keypad for a game of higher, lower, and controlling LEDs. Perfect for practicing user input and visual feedback. Don't forget to like, comment, and subscribe for more awesome projects.